In the previous video lecture, we examined the universal laws and principle called theory axiom or Ifa axiom. These are 8 universal principles or laws that underlie existence, the whole of nature, and they form the core of the theory. So you can, they actually a more elaborate form of the theory in CENProject. Today we are going to talk about Ifa numbers, also called theory numbers. So this the core of the theory is this framework called Ifa Mathematics or theory mathematics. The theory has a lot of dimensions or elements. Some of these are mathematics, which is theory mathematics. You have the physical aspect of the theory, which is theory physics or physical theory. You have the chemical aspect of this universal theory, which is chemical theory or theory chemistry. The same thing applies to all other fields and disciplines. The theory extends to all these the disciplines, all these fields of knowledge. It has dimensions in all of them. So the mathematical aspect of the theory forms its core, and that is what we call Ifa mathematics or theory mathematics. As I said in the previous video lecture, Ifa mathematics is the scientific study of energies that manifest as all elements of nature, including all fields and disciplines. So in Ifa mathematics, we are simply studying all elements of nature, all fields and disciplines in a holistic and integrated manner, focusing on their core, that is their energy. Now, this approach is different from the popular approaches in schools and institutions all across the world, which focus on physical manifestation of elements of nature. In Ifa mathematics, in the theory, we focus on the core of any element of nature. We study all of them in a holistic and interconnected manner using Ifa number and other mathematical structures we developed in CENProject. Now let's start with Ifa number. What do you mean by Ifa number? So yeah, you know numbers mean different things to different mathematicians. To some mathematicians, numbers are mathematical objects. To others, uh, numbers could mean other things. Probably they are artifacts, they are elements of the mathematical universe, and so on and so forth. Now, there are different ways people approach number. There are different ways people define numbers. Some regard numbers as some numbers like prime numbers as the basic building blocks of all numbers. Regardless of how mathematicians define numbers, one key element underlies all these definitions, which is numbers are forms of energy or CEN. We are simply saying that numbers are states of mind. That's what we mean in simpler terms. By state of mind, we mean that they are just ideas that people uh, come up with. So we see them as uh, objects or elements in the mathematical universe, which are forms of energy. So if a number is a form of energy, you define a number. So if you choose any number, n can be natural numbers, that's counting numbers. It can be integer, it can be rational number, irrational, that's real number, it can be complex number, and so on and so forth, even quaternions. It can be any number. So In Ifa Mathematics, we define that number as a state of energy. We define it as energy, as a form of energy. This is how we define a number in Ifa Mathematics. So if we use any number as an example, so let's start with natural number. So natural numbers are counting numbers. I think we are all familiar with that. So we start with counting numbers, which are natural numbers. So examples of natural numbers are 1, 2, 3, 4, 5 till infinity. So they are just numbers we use to count in our everyday activities. So if you take any number in this set, it is an infinite set. If you take any element of this set, we define it as energy, as Cn. So to differentiate this one from the number you are familiar with, we now use this Ifa infinity as the subscript. So as an Ifa number, when it is defined as an Ifa number in the theory, so this set becomes, so we just simply use this as the subscript. So we have this. This means that this number here is a state of energy or form of energy. It's a state of mind. Now this is where we are focusing on the core of these numbers. So examples are the elements of this universe, natural numbers are 1, 1 sub Ifa infinity, do infinity, then we continue in that manner. So continue. Where n is where n where n is a counting number. N is a counting number. So if you look at this number, these numbers are energies. They are not the normal number we are familiar with in mathematics and math. These are energy and they are zeros, they are vacuums. Yeah, what we are saying is that we take a number and we combine it with its dual, with its opposite. Combine it with its dual. That is its opposite. So that combination now, it now gives us this entanglement or this it gives us 0. Yeah, we are combining plus 1 because 1 sub j infinity, this is theory 1. 1 sub is equal to 1 plus minus 1. So which gives us 0. So all these numbers here, they are zeros. These are zeros. So they are just vacuum. So they give us vacuum or entanglements. So this is the composition operation that we have done here. So you can do the same thing for any of the objects of this of the universe of natural numbers, of this infinite set. So these are zeros of vacuum. They just represent energy. That's the energy of these natural numbers. So if you move on to integers, move on to there, we do the same operation, we do the same composition operation. Then we now form Ifa numbers for integers as well, which are also 0. So you can do the same thing for real numbers, for complex numbers, for quaternions, we move on to octonions, sedenions, and even other numbers like Grassmannian numbers, any number at all, whether it's even Clifford numbers, any number, periodic numbers, any number that in mathematics, you can do the same operation for it. You just need to find, you just take the number and you compose it, because every number has a dual, has opposite. There is no number in existence that doesn't have an opposite. So you just combine or compose that number with its opposite to give us 0 to form an Ifa number or theory number. So these numbers are universal numbers. They are universal numbers. They are different from the numbers that we are familiar with. Why do we call them universal numbers? Because you can use them to integrate and interconnect, internetwork all fields and disciplines. So that's why we call them universal numbers, because they belong to they form the core of this universal system, theory. So if you, by the time we do this operation for all numbers in existence, you can see that 0 is common to all of them. We remove after this natural number, we do the same thing for integers. Any number at all, we generate these zeros, this vacuum. These zeros actually represent the energy of those numbers. The vacuums there, they represent the energy of those numbers. The Yoruba people call this energy Odu. ODU. That's what they call the energy or spirit of that number. So it is called energy or spirit, which is Odu in Yoruba. So the energy of these numbers are the spirits or the spirit of the number. You know, it's not something you can see with the naked eye. That's why we code it with 0. But this 0 also has its opposite, which is its dual. Before this number manifested in the physical world, they first existed in an unconscious state, which is now they become conscious, because they become conscious in our minds. Before that, they were unconscious, which means they were opposites. The opposite of 0 is 1. So we now form the dual of all these vacuums, which represent the unconscious states of these numbers, all numbers in existence. So you can get for each of the vacuum or 0 for any number, for each of the universal 0 for any number, you can generate its opposite or its dual, which is 1. So just like we have infinities or double infinities of zeros for all number systems in existence, even the ones that haven't been built, we have these zeros for all of them, because all of them have their dual or opposite. That's why we call them numbers. Just like we have that, we also have their dual. We also have infinities of this dual, which represent the non-conscious state of those numbers before they manifest in the physical world. Now, these universal zeros and 1 are all the numbers that really exist. You cannot build any number system outside the universal 0 and universal 1. So we call the universal 0 and universal 1, we call them Ifa pair. So that's how we came about. From this universal 0 and universal 1, we have universal 0, which is theory 0. Now, if you look at this, this is a universe of 0 that you're looking at. It's a universe of 0. All numbers in existence they live within this universe. Universal 0. So in Ifa Mathematics, we call this the numbers of everything theorem. So this is the number of everything. These are there is no number that anybody can build that exists outside the system. It's not possible to build any number that exists outside this system, because for any number you develop, that number has its opposite or dual, and when you compose that number with its opposite, it generates zero. That forms the energy of that number. You have the energy, the number composed with its pair, so it forms the energy of the number. So the opposite. Now, if you say that you want to develop a number outside the system, you now call those numbers impossible numbers. This is the universe of all possible numbers. The universe of all possible numbers, as stated in the numbers of everything theorem, which we also call an application of Ifa master theorem, which I examined in the paper for this for Ifa mathematics. The universe of all possible numbers. Now, some people will say, is it probably we can build number system outside this universe? That means they want to develop impossible numbers, which is the dual or opposite of possible numbers. So the dual of this one is 1. So what they want to build is the elements of this universe. So this is the universal 1. So this is the universe of all impossible numbers. So if people say, they want to build a number outside this system, then that number we build a universe for those numbers, for those impossible numbers. So this is the universe of all impossible numbers. It is the dual of this first one. So these ones are theory 0 and theory 1. We also call them theory 0, theory 1. So these are actually all numbers in existence, as I said earlier. So they are just the same way of representing the same entity. So what I'm saying here is that all numbers in existence are forms of universal 0, and their dual or the opposite are forms of universal 1. So this how we came about the so this is how we came about this set. So if you apply this theorem, this is the Ifa master theorem, or the theory theorem in Ifa mathematics, which I examined in the paper for this for the theory. So we have this how I came about this. So we have represent the universe of natural numbers as energy. Right? That represent as an Ifa numbers as as states or forms of energy. Then we move on to integer. Move on to real numbers. So you can see now we are building all the numbers in existence, all possible numbers. Even in the next 1 million years, any mathematician that builds a number system, that number will be contained within this universe. No number can exist outside this system, because all numbers are forms of energy. They are built with the human brain. So it's not possible to build any number that exists outside this system, since energy is fundamental to all things. So we move on to complex numbers. We have quaternions. We have octonions. One, two, three, four, five, six. Then we have sedenions. So there are many other numbers. So we just generalize it. Generalize it. We use Ifa infinity to generalize. That means you can apply it to that formula to any number, it applies to it. That means you can use this for any number, it applies to the number. So we call this the numbers of everything. That's all possible numbers. Num OE. The numbers of everything is a key aspect of the theory of everything. That is num OE. So we also generate this thing as its dual. These are all possible numbers. Then we have the dual of this. That is, so as I said earlier, each of these is what? They are vacuums, they are zeros. So they give us the core or the energy of all number systems. The dual of this is 1. Again, don't let us forget that these zeros and 1, they are universal entities. They are not the ordinary zeros in math that we know. So this is defined as, so we take the dual of each of them. So we have, so we take the dual of that. So these are, so we call this, so we just differentiate this one from the first one by changing this U to O. So we call this the number, this is the numbers of everything, and we call this the numbers of everything. Numbers of everything. So these are all impossible numbers. So this is the number. These are, we call this Ifa numbers, and this one Ifa numbers. So they are dual opposite of one another. So we just simply summarize the whole. So these sets are very gigantic. They are gigantic entities. So this is a universe. This is a universe of numbers. Another universe of numbers. So they form the multiverses of all numbers possible. So you can just summarize everything. You can just represent them using the system called Ifa pair. So you just represent them as Ifa pair. So we invented, so we just summarize this with this system called Ifa pair. So we invented this structure. So we invented this structure which is called squackets. Squackets. So we use this one to compose two opposites. We use them to compose, that we use them to combine two opposites. That's to form zero. So if we compose this one with this, it gives us this 0. And if we do the reverse operation, it gives us this one. That's the dual of the operation. So all those universes of numbers that we wrote, the Ifa numbers or natural number, Ifa natural number, integers, and so on and so forth, and the possible the duals of those universes. This is a shortened way of writing it. Now, this is a universal binary language that we use to express all elements of nature in the theory, the universal binary language. So the universal binary language, this is the language of the theories. It is also called Ifa language or theory language or CN language. We use this language to represent all fields and disciplines, to express all fields and disciplines. That means in schools and institutions all around the world, where people are studying fields and disciplines, they use different languages to represent the fields of study. In the main disciplines in the theory, we represent them using mathematically. We represent them using Ifa mathematics in strings of zeros, universal zeros, and universal ones. Now, this is a universal language. That means all humans across all cultures around the world, whether they are blacks, white, Asians, any woman from any background, creed, or age, we all understand mathematics. Mathematics is a universal language that every human understands. So we use that language, this universal binary language, to represent, to code all fields and disciplines in a unified and holistic manner. That is the utility of Ifa mathematics and these structures. So in the next lecture, we are going to look at Ifa algebra. So we have built tons of meta-mathematical structures in Ifa mathematics to achieve our aim. That means to study all fields and disciplines in a holistic and integrated manner. So that is all for today's lecture. Thank you.